Okay, welcome to Zalot Studio channel. So let's to be discussing about how much charge is being stored on the capacitor. How much charge is being stored on the capacitor. That means the capacitance of a capacitor. So the capacitance of a capacitor is E times A over D. A mean the plate area, and D, that is the separation between the plate, positive plate to negative plate, that is 10 millimeter. It will be decreasing or increasing. Okay, this is the separation between the plate, that nearly 10 millimeter. So and epsilon mean the free space. Okay, constant, that's the permeabilities of material, the permeability of the material when it be the air or free space or vacuum, that is 8.85 times 10 to the power of minus 19 Faraday per meter. Therefore in this condition, the supplied voltage is 1.5 V, and the capacitance, that is 0.18 picofarad. Let to be calculate the values. Okay, here 8.85 picofarad times the area, that area is 200 millimeter, divided by separation distance, that is 10. This is equivalent with 177, which is nearly 18 or 118. So here 0.18 picofarad mean equivalent. So, and again the plate of charge, the top plate or the bottom plate of charge. So you know Q is equals to C times V, capacitance times voltage potential difference, or capacitance is equals to Q over V. So to be getting the plate charge Q, so Q is equals to C times V. You know C is getting that 0.18 picofarad times the voltage drop into the plate, that is 1.5 volt. Let me calculate the value, that is 0.27 times 1.5. It get what? It to be getting what? The charge Q is equals to C times V. C is the capacitance, that is 0.18 times V, what is 1.5 volt. Here equivalent with 0.27 picofarad. So when to be increasing the voltage or decreasing the voltage, the charge stored into the capacitor is what decreases. When to be increasing the potential difference, the supply voltage, that the capacitance of a capacitor to be what? Increasing to be change the plate. Okay, here, and the capacitance of a capacitor, that interdependent with the plate area. When the plate area is decreases the capacitance, here the capacitance of capacitor is what? Decreases. When to be increasing the plate area, plate area, okay, the capacitance of a capacitor is increases, which means the capacitance of a capacitor is directly proportional with the plate area, and come to here, and the separation between the two plates is decreasing, okay. Here the capacitance of a capacitor is increase, which means capacitance is inversely proportional with what? Separation distance between the two plate. When to be increasing the plate area, okay, the capacitance of a capacitor is what? Increases, which included what? Which mean what? The plate area is directly proportional with, or the capacitance is directly proportional with the plate area of a capacitor. Here, when to be increasing the separation distance, the capacitance of a capacitor is decreases here. When the separation distance between the plate is decreases here, the ability to be storing the charge would be what? Decreases. And let to be connected to the battery and the resistance. When in this situation the plate area of the capacitor is 200 millimeter square and the separation distance is 10 millimeter, and disconnecting from the battery, the capacitor is disconnecting into from the battery. So okay, the capacitor is disconnecting from the battery, and it stored the energies here 0.17 picocoulombs and connecting into the resistance, okay. Just charge will be what? Discharging. It dissipates from the plate, okay. The time discharging is nearly small amount of time, and again charging from the battery. The capacitor is charging from the battery, and again what? To connect the resistance or the load, okay. It also discharging. So when a capacitor is discharges through a resistor with an or bulb, the capacitor acts like what? A battery to derive a current through the resistance. But unlike battery, it is what? The voltage drop rapidly as its charge drain away. Let to be increase the capacitance. Which means increasing the plate area and decreasing the separation area, okay. Here the energy stored into the capacitor is increasing, and the plate charge is also increasing, and disconnect into from the batteries and connecting into the resistance or the bulb, okay. Here discharge such a lot, it take a lot, C times R, C times R mean the discharging time. C mean what? The capacitance, and R mean the resistance or the load. Okay. Here nearly what? The energies is 0, but the plate of charges is also nearly what? 0. So disconnecting from the resistance and connect again, automatically what? The plate is charging by the charge and connecting into the resistance. Okay. Just like here it is the discharging of a capacitor. Okay, the energy is dissipating into nearly 0 joule, 0 picojoule or 0 joules. So need to be measure the voltage into the plate. What about? Okay, what do you see? Let to be disconnect and connecting. That is, the battery is 1.5 volt, and connecting into the resistance, the voltage is dropping from 1.5 volt to is 0. or 0.0 volts, 0.0 volts. Okay, this is the capacitance, okay, or the capacity of the capacitor. So this is all about part 2, capacitor and capacitance. Thank you for watching. Please subscribe and write the comment and like. Thank you.